marketing. Be invited in cool places like Tel Aviv. Great software.
Seriously, that's all you got?
Yeah.
You're ready?
You really want to get into that?
You can use DNA.
Deploy those robots, but full performance.
Hello, everyone. It's nice to be here in Israel. A lot of people here. Anyway, yeah, I'm Miha, and I like turtles. No, not really. I like emoji though. You have so many scripts. You have Cyrillic, Latinic, and then you come here and it's like Hebrew and Arabic. I have no clue what those things are. I can't learn that. But emoji is simple. You don't need to learn it. You just understand it. Everyone understands it. I guess this is the script of the future, and just get used to it. We're gonna write in this very soon. Okay, so speaking about coming here. Oh, okay, right. So I am from Slovenia. I don't know how many of you know where that is. It's 2,330 kilometers away. I checked. And yeah, coming here was a interesting experience. I got asked a lot of questions. They went through all my stuff, my hand luggage, my luggage that I left, everything. They checked everything. They used it weird thingy and they put it all over me and my shoes for some reason, which were really dirty, and I was like, where are you gonna put that? And they did some shit. Then they asked me to they asked me to go to a really tiny room which was like this big, and I had to wait there for like 10 minutes. And then they asked me a lot of more questions. And at this point they asked like, why am I going here and what do I do? And I said, I'm gonna give a talk. I'm a software developer. And they said, who do you work for? I said, TopTal. They said, what's that? I'm like, it's a cool company, blah blah blah. And like, what do you do? I said, I'm a developer. Again, like they ask the same questions, and you're like answer. And then they said, do you have a business card? And I do have business cards, and I gave them my business cards. And at that point, I realized what it says on my business card. It's yeah, it wasn't funny. It wasn't funny then. Explaining to custom officers like what's a rubber duck and what's a senior rubber duck, and yeah, it was it was interesting. Yeah, so as I said, I work for TopTal. It's a great company, and I have to thank them for getting me here, for paying for my trip, which was expensive, and it's really expensive here as well. But you know, I come here just for you, so thank you. Right, so we're a pretty big company, and we're growing, and like crazy. A lot of people ask me like how it is to work for TopTal, and I say it's great. It's the best company I work for. You maybe seen these guys here around. We are all from TopTal. It's really great. I work remotely. I work from my home. I get to choose my working hours. I work when I want, where I want, wherever. The only downside really is my boss there. He's a real pain. Oh, hi Wojidar. No, my boss is the best, as I was saying. It's really great to work with him. He's an amazing guy. Yeah. Anyway, as everyone said here the last day, we're hiring, and like everyone said, I have stickers. So if you want stickers, come to me. If you want to work for TopTal, come to me as well. I'm also an interviewer, so you know what to do. Anyway, a quick story about me. Like I said, I'm a senior rubber duck. I organize Ruby Slovenia, which is local Ruby meetup group. I guess I was better suited to give a talk yesterday when people didn't care so much about really low level performance, because we Ruby developers, we don't care about this shit. It's slow, like whatever. But I'm here anyway. I run. I'm not really performant here as well, but I go long distances, so it's pretty cool. I take photos as well. I'm an event photographer, not as much as I used to be, but I do that. It's fun. I like coffee. I like coffee very, very much. If you wanna talk coffee, come to me. This is how my Instagram feed looks like. It's just coffee. I spend a lot of money on my coffee and on the equipment I have. So yeah, if you wanna talk coffee, come to me. Also, I like keyboards, and no matter what this guy tells you, like the new MacBook has a shitty keyboard. It's like you should not use this under any circumstance. That's the only, well, not this particular one, but mechanical keyboards are. And if you're interested in mechanical keyboards, I have a tester of switches here. So if you want to talk keyboards, come see me later. No, I'm serious about this, and yeah, I'm special. Any of these things interest you, come to me. I have Ruby Slovenia stickers as well. So yeah, plenty of stickers. It's cool to visit me. Let's go back. Flame graphs. So, how many of you ever heard of flame graphs? That's awesome. That's much more than the usually. It's like half the crowd. It's great. So, flame graphs are basically the only time when you're allowed to use this keynote effect. Seriously. Right, so no, but for real. There are interactive visualization, it's a hard word, of stack traces. They tell you like what's happening on the processor. They are very useful from beginners to experts, so you don't have to know all the details that were in the previous talks, like nanoseconds and microseconds and all that, to be able to use this. It helps you if you know, but like even if you don't, you can use this. They can be used for a lot of different things. Today I'm gonna show them how they are used for analyzing how software is consuming CPU, but they can be used for I/O, for memory, for lots of other things. Basically anything that can produce stack traces can be turned into a flame graph. Brandon Gregg is the guy, I hope you can see this. Brandon Gregg is the guy who invented those. He works at Netflix. I think he still works there anyway. So what he did, what the problem he had, they had some slowdowns somewhere at Netflix, you know, too many people, Netflix and chill. And they did like an analysis. They used I think this is either strace or dtrace or something like that. Anyway, they used a CPU profiler, and it gives you something like this. And this is like after being uniqued and counted and everything. And like you can't really read this, and it's really hard to tell like where are the real bottlenecks. So he spent a lot of time, like he has a really great post how he came to that, but basically eventually he came to a realization that he has to visualize this somehow, and he came up with this. So let's see this again. This was before, and this is the same data. Like, oh, okay, I see this is, sometimes this is less time, this took more time. That's awesome. Like, when I saw this for the first time, I was like, whoa, lots of colors, flames. What is this? So, let me explain it to you real fast. Every box that you saw represents a function, which is a merged stack frame, whatever. It's one function. It could be from a low-level OS code. It could be from higher level, your app code, doesn't matter. The y-axis, so the vertical, shows stack depth. You basically go like this is what the initial call was, and it called this method, and that called that method, and that called that method, and so up. Or if you go down, you see, okay, so what's my code path, what called me, and you can just go down, oh, so this method was called by this method, and so on. The top function is basically the one who is at the CPU at the time of profiling, and it led directly to the profiling event. And everything beneath it, like I said, is ancestry. Number of samples are all in percent. So basically, that you set a start time when you start profiling and an end time, and you end up with what we saw before is like a lot of text, and it's fixed. So it's not real time. You have a fixed amount of time, and the thing transformed this into a graph that's basically relative. The full width is 100%, and then it goes down. And the x-axis are the stack trace, but they are merged together, and they are sorted alphabetically. This was the biggest reveal for me. It does not happen sequentially. It's like the flame or the methods are not what was called sequentially. It's reordered by alphabet, because if you do that, you can then merge it. I'll show this later. And yeah, like I said, the box width shows the total time it was on CPU, and it's in percents because the total time is 100%. And that's basically it, and that's simple, right? Right, so let's look at things a little deeper. So sampling, right? We decide that we will sample every n thing. So we set a time interval. It can be seconds, probably not very useful, milliseconds, nanoseconds, whatever. You go however deep you want to go. And at every point you observe what's going on and you record it. This is what the tools like strace, dtrace, and all of those they do. Flame graphs is only a way of showing this data. They do this stuff, and they basically tell you what action called a different action, and so on. So let's look at my day, and let's see like in 1 minute intervals. Let's say I'm doing my job, and like we start sampling now, and every minute we look what I'm doing. So at this time I'm enjoying my day. Well, not really, I'm reading emails. Who's enjoying emails? And yeah, and I have this. So it's my day. Currently, that's the only thing that's happening. I'm reading emails, and let's put this down in a graph. Right, so we have it here. The next thing, like the next minute, what I'm doing, I'm replying to emails. So we added another one. And then I close this shit, and you see me a minute later writing code. Then I'm writing some tests. I'm running them. I'm then fixing some tests, because tests. Then I just like, if let's look at the previous one. Like I was writing tests, running tests, fixing tests, but then like what, 8 minutes later, I'm just writing code and running tests, because I've written the tests already. So the same method could be called like from a different places, right? It can be called directly from writing tests, running tests, or writing code, running tests. Right? It doesn't matter. But you see the colors stay the same. Like these colors are the same. Colors are basically used for separating it somehow. On the example I'll give later, it's just gems, but like it doesn't matter. They can show whatever you want. In this case, I'm showing the method name. And then yeah, I'm making an espresso because I can't handle this out. Joining my espresso, reading emails, and then I go back to writing code, running tests, reading emails, replying to emails, and I end up with this. Right, so this is the flame graph of my day at this point. See how this is my day. This is like reading emails, writing code, fixing tests, running tests, whatever. Everything is here. Right, and even there's even making an espresso. It takes some time, but it's worth it. It's totally worth it. So what we do then, because I basically hinted at before, we group this. Right, so we sorted out, let's say alphabetically. I didn't in this case, but whatever. We sort it so we have the same things together, right? And what we can do after this is group it actually. So, and then you see my day. I was reading emails. I was replying to emails. and then you have me writing code, you have writing tests, and now, as I said before, running tests is going to be on 2 of them, right? Those 2 will not be grouped because the code path was different. But you see, I was running tests like 4 minutes, or like at 4 times that we observed I was running tests. And I was fixing tests for 1 unit, and of course, making an espresso. Okay, so that's how it is as far as sampling goes. Now, the actual graph here will have a bit different. We have a couple of method names like A, B, C, D, E, F, G, H. And every box, like I said, represents a function. Here we get this already, right? We're great. So yeah, every one of them is a function. They show stack depth. So the y-axis, the top, basically, was on the CPU when we were profiling, and the other one was the stack trace. It's the ancestry. And yeah. Right, so if you look at F or E, you can see like everything below it is the ancestry. So the code path goes up, the ancestry goes down. It's very simple to understand. It's ordered by alphabet, so in this case I have B before G and C before H and D before E. It's just so, like I said, that we can group them together. And the whole thing is the total time on CPU at the time we were sampling. So now it's your turn. Let's do a quick Q&A. Which function is on the CPU most? No one was listening. F is on the CPU most, because F is the top function. The top function is the one that led to the profiling event. This is only the code path. This is only the ancestry. So yeah, A called B, which called C, which called F, E, which called F. But F was the method that was on the CPU at the profiling time. So when you looked at my day, you saw that I was fixing tests, and this doesn't say that at that time I was having my day. This was just the top function was fixing tests. Okay, let's do better this time. Why is F on CPU? Yes, exactly, because it was called by E and E was called by C, and right. Okay, got it. Yay! Yours. Is everyone sleeping already? Sorry. Yeah. So how does B compare to G? Yeah, it's bigger. Yeah, good. So bigger means that it's like it's running, so it's present about 10 times more than G. It's so like if we have a nanosecond or whatever thing G in the whole process, it probably doesn't make sense to do any optimizations there. We can do it, but might not be worth it. Right, another one. Why are we running F? Yeah. Sorry? Yeah. 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 It's well, it's so you can think of this as like it might have a loop or something in it. So it was still present. It was still on the code path. The actual thing that was running was F, but F was included in E, which was included in C, which is like you go down. It'll make more sense later, hopefully. Right, so we are running F because, yeah, A chose B, so A called B, B called C, obviously, because it's directly, and C called E, and E called F. Right, so I showed this graph before. This is the original one from the post, which I suggest you read it. And I'm gonna give you a real-world example. Again, I'm a Rubyist, so I used Ruby. In Ruby, you have this gem flame graph. If you're not a Rubyist, if you're not familiar with Ruby, whatever, will not matter in this case. It uses StackProf, which is there's a C API in the Ruby 2.0 and up that basically tells you what's happening, and it shows you all the stack traces down to C. And supposedly the API has the minimum CPU overhead, so it's ideal for profiling. Sam, who wrote this, says that You can even run this in production. So you can basically start profiling when the request starts and stop profiling when it ends, and then save this somewhere, and then you can generate a flame graph out of it. If you're not a Rubyist, I'm 100% sure there's a flame graph thingy for your language, or like just run whatever. Use your language, your main language, space flame graph, go to google.com, paste it in, it's gonna be there. Right, so I'm gonna now switch to my, yeah, here we go. This is the flame graph of a thing that we had. Let me refresh it. So whenever you refresh it, it scales to the size of the window, so I better not fall here. I have a laser here, right? Ooh, awesome. Even though mouse is more useful. But so, I don't know how good you see this, but all of this are basically telling us what are colors, and in Ruby case they are, thank you. They're colored by gems. Color can represent whatever you want, but like I said, in this case they are gems. Gems, if you're not familiar with Ruby, are just packages that you can include. So yeah, we have like, here we have the Flame RB, which is the lowest one, which was run on 99.94% of the samples, which means this is the thing that called this thing, 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 and so up. And by the colors, it's easy to tell, like the block is our engine, so this is my code, and here it is again, and here it is again. And cram down is just a markdown parser, and memoist basically caches things, and so on. And the thing is, like, I'm gonna fall here, I swear. So when you, whoa, yeah, I wanted to show this, but not now. Okay, so why is it not working with me? This is really hard. Where's my mouse? Sorry for this, but it turns out it's really hard to present with one screen being there. Does anyone see my mouse? Oh, here it is. Hello. Right. Ah, yeah, this is what I wanted to show. So, like I mentioned in the first slide, it's interactive. So, as you saw with me, running tests was on different heights. The same way happens here. So these things are on different heights, but you see it's the same thing. It's the same method, and you see it here. That's like it was block, app services, graders, helpers, common in this thing, and there's 1,500 samples, and it occurred in 96.921%. But like at this point, it doesn't really matter. What you immediately see from this graph is that we have what seems like 9 similar or like exactly the same things, which means we are doing the same thing 9 times. And I didn't know this before. I thought the thing was cached, but obviously it's not. So what I did next is basically introduce a cache layer and run flame graph again. And I got something like this. The whole, those like 9 of them that were before like evened out, are now one big one, because this got significantly faster. This was like 8 times faster. And then I took a look at some more of it, and like you can see, this is all the same method that's calling itself or whatever. And as I showed before, although not intentionally, when you click anything, you see the whole stack trace, and you can see how many samples there were, how long it was on, and it helps you explore the stack. So you can just play around, and with this, like go down your code, your app code, or whatever, and you'll see it. So yeah, I cached the cram down. Oh, 5. I thought you wanted high five. Yeah, so I cached cram down, and I did here it was like 7.58 times improvement, and I did some more stuff, and I got like 10x improvement. I think that before it took almost a second. That was really slowing down our blog. By the way, you should totally check it blog.toptal.com. It's insanely good. I'm not just saying because I work at TopTal. It's really good because the people writing it are usually not working for TopTal. They are really smart people who write things there. It's really cool. So yeah, and I did some more stuff. It's a 10x improvement, and basically, if you have a slowdown in your code and you don't know what's causing it, this is an insanely good tool to use it. I could probably speed it up, but I got it from 1 second to 0.1 second, and like I said, I'm Rubyist. Good enough. Move on. There are more important problems for us. But yeah. So now what? Right? That's what you're asking. You're leaving. That's a good thing. I support that. I would leave as well. This is anyway. You're here. Let's start. You can ask me about any of these things, or you can ask someone smarter than me. Let me rephrase that. You can ask anyone else. You can read or watch blog posts. Well, obviously read blog posts and watch videos. There are a lot of great content there. I'm gonna post these slides on Speaker Deck probably. I'm gonna tweet it out, and or you can just come to me and I'll tell you where they are. And I will post like a lot of stuff there, or again, go to this google.com. It's a great thing. Write in flame graphs and find Brandon's blog post and paper. It's really good. It's much easier to use than it looks like, and it's really beneficial. Again, I have stickers, Ruby Slovenian ones. If you saw the flag before, this is like sort of a Slovenian symbol, the 3 pigs one, and it's replicated in the Ruby symbol for our group. But there's a catch. If you want a Ruby Slovenia sticker, you have to ask me something about my talk, or comment on it. That's fine as well. Or it can be about software development in general. It can be Ruby. It can be about running. It can be about coffee, keyboards, photography. Basically anything. I will not give it for free. Like, you have to ask me something, right? That's a yes. You can ask me about the stickers, and I will explain the same thing to you. Right. Okay. So thank you so much for being here.